Why is getting to Venus so difficult? Despite the fact that Venus is the closest planet to Earth in terms of distance, the last space agency mission to Venus was more than 30 years ago. Why do space agencies appear to favor Mars over Venus? Is it difficult to send spacecraft to Venus? Or is there another reason we've been sending spacecraft to this planet for more than 30 years? Stay with us to find out. Why Mars before Venus? When space agencies first began exploring the solar system, they began with the celestial bodies nearest to Earth, beginning with the Moon, the most prominent and luminous body of the night. Luna 2, also known as Lunik 2, was the first space exploration mission to reach our natural satellite. On September 12, 1959, the Soviet Union started this mission. Luna 2 was the second spacecraft in the Luna series and the first to successfully land on the Moon. Its primary goal was to impact the lunar surface, which it accomplished on September 13, 1959. Making it the first human mission to impact another celestial body in the solar system and the first human-created object to reach the Moon. After reaching the Moon, the next goal was to reach Venus, the closest planet to Earth, because we wanted to learn more about it. It was difficult to imagine what the surface or atmosphere of Venus was like before the era of space exploration because the only way to see it was through telescopes and whenever it was observed. The only thing we could see from Earth at this distance was the planet was completely covered in clouds. In the early 20th century, British astronomer Percival Lowell, well known for his studies of Mars, mused on the possibility of life on Venus. Lowell imagined Venus as a world covered in waters and rich vegetation, with numerous living forms populating all ecosystems. Others imagined a species of intelligent extraterrestrials living that globe in the same way that humans do on Earth. However, over time, telescopic views revealed that this world had no indications of life, at least not intelligent life, because if it had, we would be able to see the lights of its cities at night. Furthermore, studies with infrared pictures and spectral cameras revealed that this planet had a significant CO2 concentration. It was also far closer to the Sun than the Earth, thus it must have been much hotter. However, there was no guarantee of this. As more discoveries were discovered, the idea of life on Venus became increasingly distant from the scientific community. To determine once and for all if Venus had life or not, the Soviet Union, in collaboration with NASA, conducted many missions targeted at studying this mystery globe during the 1960s and 1970s. The Soviet spacecraft Venera 1 was the first to approach and investigate Venus in greater depth. It was published on February 12, 1961. Despite a communications failure, the mission managed to pass within 100,000 kilometers of Venus, becoming humanity's first object to approach another planet. At the same time as the Soviet Union was sending missions to Venus with the Venera spacecraft program, NASA was doing the same with the Mariner program. The program included a number of spacecraft designed to explore and research the planets closest to Earth, namely Mercury, Venus, and Mars. The Mariner 2 probe, which sailed by Venus on December 14, 1962, was the first of these missions to reach another planet. Mariner 2 was the first spacecraft to take direct measurements of Venus' atmosphere and temperature, delivering important information on the planet's characteristics. Following the partial success of the Venera 1 mission, the Soviet Venera 3 probe purposefully crashed onto Venus in 1966, becoming the first spacecraft in history to reach the surface of a planet other than Earth. Venera 4 would be the first mission to return precise data from inside Venus' atmosphere. Data from this showed that 95% of the atmosphere was carbon dioxide, and when combined with data from the Mariner 5 probe, it revealed that the pressure at the surface was substantially higher than projected 90 atmospheres. With all of this information, scientists concluded that the prospect of life on Venus was extremely remote due to the planet's severe climatic conditions. As if that weren't enough, on July 1, 1965, NASA's Mariner spacecraft sailed by Mars, returning the first photos of this planet's environment, which was vastly different from that of Venus. Following that, the Mariner 6 and 7 missions would return further data from Mars, demonstrating that this planet had more favorable circumstances for life. Unlike Venus, which was a hot and deadly world, Mars is a desert globe with no breathable air, but its moderate temperatures are more similar to those of Earth. This revelation forced space organizations to abandon Venus and focus all of their efforts on Mars, which appeared to be a more conducive planet to living beings or could even have life in the form of microbes. Is it difficult to reach Venus? No, when we compare the distances and difficulties of sending spacecraft to other planets to Venus. It is not more difficult to get to Venus than to other planets. What is challenging is landing a spacecraft on Venus. A difficult challenge to overcome. Even though the Venera and Mariner probes reached Venus in the 1960s, getting a probe to descend near the planet and land took a lot of effort. Venus has a dense and heavy atmosphere. For comparison, Earth's atmosphere is mostly made up of nitrogen and oxygen. However, the atmosphere of Venus is 95% carbon dioxide. The rest is nitrogen, sulfur dioxide, SO2, helium He, and sulfuric acid H2SO4. Yes, as you may have heard, sulfuric acid exists in Venus's atmosphere. Because of this gas composition, the air on Venus is incredibly heavy and dense, with an atmospheric pressure 90 times that of our planet. The only way to experience this pressure on Earth is to dive about 1 kilometer down into the water. This means that in order to arrive on Venus, the spaceship must be as strong as a submarine and have enough insulation to survive extreme temperatures. Previous probes to Venus were equipped with thermal insulation that allowed them to withstand temperatures of more than 480 degrees Celsius in the planet's atmosphere. A human-manned spacecraft should have a comparable coating that can support more than 90% of the Earth's atmosphere. The only method to accomplish this is with a subsurface coating. A spaceship with these features would be so heavy that it could not be sent into space with any rocket. To build a spacecraft capable of landing on Venus, we would have to launch it into low Earth orbit in pieces and assemble it in space, like we did with the International Space Station. Too close to the Sun. Another issue that makes it difficult for spacecraft to approach Venus is its proximity to the Sun, which causes acceleration as well as heat. Venus has a 28% closer orbit to the Sun than Earth. As a result, a spaceship headed toward Venus must travel more than 41 million kilometers into the Sun's gravitational well, losing some of its potential energy as it is converted to kinetic energy. This means that as the spacecraft comes closer to the Sun, its speed increases, making it difficult to control and, as a result, difficult to slow down enough to position it in orbit around Venus. This is analogous to flying and needing to land just when the plane's speed reaches its maximum. To accomplish this, the aircraft must conduct a quick braking maneuver with almost no failure because even the smallest mistake could destroy the vehicle. Similarly, as a spacecraft reaches the inner planets, such as Mercury and Venus, it accelerates so rapidly that the braking process is one of the most dangerous, as the smallest failure could result in the spacecraft's loss. If the spaceship brakes too hard, it will fall uncontrollably toward the planet. If it brakes too little, it will continue on its route to the Sun and get lost in space. What more could possibly complicate matters? In addition to the acceleration owing to potential energy created by the Sun's gravitational well, another aspect that makes landing on Venus difficult is the solar radiation itself. Because the amount of solar radiation received by a spacecraft grows as it approaches the Sun, missions must consider utilizing thermal coatings to safeguard all of the spacecraft's systems and instruments from being burned by solar radiation and wind. When spacecraft fly close to Venus, they receive twice as much radiation as when they are close to Earth. This can cause communication system breakdowns. As a result, the flyby and approach maneuvers to Venus were performed automatically using artificial intelligence. But if braking and landing are so dangerous, why are they left to computers and artificial intelligence? The main cause is geographical remoteness. Between Earth and Venus, the shortest distance is 41 million kilometers. Remember that the speed of light in a vacuum is 300,000 kilometers per second. Therefore, a signal sent from Earth would take approximately 2 minutes and 28 seconds, or 2.5 minutes, to reach Venus. A transmission back and forth between Earth and Venus would take about 5 minutes. If the spaceship were on a collision course with an asteroid, it would have to perform an emergency redirection maneuver, but it would be unable to do so because the reaction would take 5 minutes to arrive. Instead, it must be designed with explicit and specific instructions to automatically reverse orientation and therefore prevent collision with the asteroid. That is why the entire process of directing and landing a spaceship is left to an artificial intelligence, which will follow all orders to the letter, without errors, with high precision, and without 5-minute delays. That's why landing on Venus is so difficult. New missions to Venus, Da Vinci Plus and Veritas. Although Venus is no longer a planet where scientists look for life, it is nevertheless an intriguing world with many similarities to our own. Currently, the discoveries of the second nearest planet to the Sun indicate that, in the past, Venus was a much friendlier world to life and even possessed vast pools of water like Earth. However, something on Venus caused it to become what it is today. Studying this planet allows us to better understand what caused the changes on Venus and how we can apply what we've learned to keep the same thing from occurring to our world. That is why NASA intends to return to Venus with the Da Vinci Plus and Veritas missions this decade. Da Vinci Plus is a spherical probe that will land on Venus's surface to examine the composition of the planet's atmosphere, understand how it arose and evolved, and discover if the planet ever had an ocean. Veritas will consist of an orbiter deployed in low orbit above Venus to survey its surface, assess its geological history, and explain why it evolved so differently from Earth. What fresh mysteries about this fascinating planet will these expeditions reveal? Will we ever know for certain whether Venus once had life? Please let us know in the comments if you'd want us to develop a video outlining the new missions that will examine the planet Venus in greater detail.